Hello my dear students, how are you doing? I hope all of you are doing fantastic with the subject physics and your life, right? So this is what we studied last. We studied about the supplementary units. Now we will be discussing another very important topic of the physics. The name of the topic is going to be, let me write it for you guys. The topic is dimensions. The topic is dimensions. See, I told you already that till now we have discussed about units, right? Till now we discussed about the units. The units are two types. One are the basic units or the fundamental units, another are the derived units, right? So just to summarize, the basic units were your please speak up with me. The basic units were length, mass, time, light intensity, molecules, electricity current, heat, temperature. So these were the basic units which we studied, right? Now I am coming to a word named as dimensions. This word dimension has a very special meaning in the subject physics. Let me repeat it. This has a special meaning in the physics. I will write it. Has a spatial meaning. Now when I say spatial meaning, what is the reference here? Has a spatial meaning. I'll explain this to all of you with the help of an example. Now when we measure some height, some circumference or the radius, when we measure distance between two places, when we measure anything in the form of the distance, how we measure it? We measure it with the help of meters, centimeters, inches, feet, or a number of such dimensions, right? So in order to provide the uniformity to the word dimension, to all the distances, I am giving only one word. To all the distances, I am giving one word, that is length. All of you must be able to realize it that meter, centimeter, inches, feet, all of these are what? All of these are distances. That means all of them are what? They are length, right? And I am representing the word length with the English letter L. This is what? L. So wherever you will see L, what it will be representing in the physics, it will be representing the distances. Now let me speak up again and let me tell you, this is the first dimension, right? Let me tell you again. Now when I say what is the significance of time in your watch or the stopwatch, so you will be saying, sir, I measure the time either in the seconds or in the minutes or in the hours or in the days or in the months or in the weeks or in the years. But everything here is representing what? Time. So time, second parameter, when I say, this is just an example to make you people understand time. When I say time, I represent time by T. It can be measured in seconds, it can be measured in minutes, it can be measured in hours, it can be measured in weeks, it can be measured in days, etc., including years, decades, centuries, millennium, everything is included, but there is a standard notation to the time, that is your T, right? And here L is a dimension. Length, for length, what is the dimension? L. What is the notation of the dimension length? The notation of the dimension length is L. What is the notation of the dimension time? It is T. Similarly, when I say mass, we write that mass is represented by M. Whereas the mass can be measured in gram, can be measured in kgs, can be measured in tons, can be measured in quintals, right? So whatever the etc., whatever the measurement unit is, the dimension is mass and the notation of the dimension is M. I hope you guys are getting clear with it now. What are the dimensions? Right? All right. See, there is one confusion which generally come in the mind of the students. What is the difference between the unit and the dimension? right? This is a general confusion in the mind of the students. I'll explain you this concept in next 5 minutes, right? See, both of these unit and dimensions are used for the measurements. Measurement of the length, measurement of the mass, measurement of time, measurement of anything on this planet. Physical quantities measurement. That is what physics is all about, right? But if I say gram, it is a unit. If I say kilogram, it is a unit. If I say ton, it is a unit. But when I say mass, when I say m, it is a dimension. So length is a dimension representing all the units of what? Distance. I am repeating it. Time t is what? A dimension representing all the units of time. I am repeating it. Mass m is the dimension representing all the units of measuring weight or mass. Got the concept? So unit is a specified concept, dimension is a generalized concept, right? So this is the difference between the two, right? Now let us proceed to the next part of it. Let us feel more about the dimensions, right? You can write more also here. We have written distance, time, mass, and you may write etc. So here we declare the completion of this particular slide. Let us move to the next slide. Now let us feel what dimensions are actually. Dimensions are powers raised to 2. Dimensions are powers raised to. I am repeating it. What is dimension? Dimensions are powers raised to fundamental quantities. Raised to fundamental quantities. To fundamental. Now read this line 3 times. Now read this line 3 times and I'll explain you the details of it in the coming lines, right? How? I'll tell you. And now I want to express, I'll give you 3 classifications here, right? Right. First classification is coming from length, as we always start with length, right? When I write length, try to understand my point. When I write length, if I say, please try to understand, if I say what is the height of a particular box, suppose the height is 6 meters. 6 meters. What is the meaning of it? Meaning of it is that height is having L dimension. Height is having L dimension. And what is the power raised to this? The power raised to this is 1, isn't it? The power raised to this is 1. Now, the second will make it even clearer to you. Suppose width of a particular box is 6 meters again. The width of a particular box is 6 meters again. Now, when I say this is again what? A distance can be represented another L, that is again 1. But when I say what is the area? What is the area? You will be saying area is nothing but your height into width. Which area we will be discussing, cross-sectional area or surface area, that is a separate concept. But for now, the point is just to understand the difference between the powers raised. When I say height is your 1L, L1, and this is another L1, which will make the area as L to the power 2. You obviously know that when you multiply, let me take another color to explain to you guys. Now this will be what? 6 meter into 6 meter, that is making 36 meter square. That is making it 36 meter square. Now this 36 meter square is what? Nothing but your area. Similarly, like we raised the power 2 here, we are raising the power 2 here on the dimension as well. We are raising the power 2 on the dimension as well. So dimensions are nothing but they are powers raised to fundamental quantities. Now when I want to understand the fundamental quantity length in the form of area, I am repeating it, when I want to understand the fundamental quantity length in the terms of area, I will do what? I will raise the power 2 to the dimension L. I will raise power 2 to the dimension L. Let me give you another example. And this example is your volume. Now this example I'll quote from, let us write with white only. I'll quote with volume. Now when I say volume, you already have height, you already have width, right? Now let me write again the third parameter. The length is given by another 6 meter, and this is again your L to the power 1. But when I write volume, how you guys will be writing the volume? The volume will be L into B into H, that is your volume. Now when I write it, that is 6 meter into 6 meter into 6 meter, this is giving you what? 36 into 6, whatever the answer may be, it is giving you a meter cube. This is giving you a meter cube. Similarly, when I see it as a dimension, when I see it as per the dimensions, it will be what? 1L for this length, so L to the power 1. Another L for this width, that is L to the power 1. Another L for this, that is L to the power 1. What it will be? It will be L to the power 3. The resultant is coming out to be L cube. So again, if I want to represent the volume as a dimension, it is coming out to be L cube. So what is the meaning of it? A dimension is the power raised to the fundamental quantities. What is the fundamental quantity? The fundamental quantity is L, and cube is the power raised to it. I am repeating it again. Fundamental quantity is L and volume is what? The power 3 raised to the fundamental quantity. And when the power raised to this is 2, what it is forming? It is forming your area. I hope the concept is clear to you guys. Right? So let me summarize it again. To you guys. What? Length is a fundamental unit, a fundamental physical quantity. When I am raising power 2 to it, it is forming area. When I am raising power 3 to it, it is forming volume. I hope it is clear to you. Now, this is when we are dealing with only one fundamental unit. Now here, on this one particular column, we will be dealing with two fundamental quantities at a time, and those two fundamental quantities are length and time. Let us see this. Now, when I write speed, what is the formula of the speed? When I write speed, what is the formula of the speed? All of you, come on with me. Speed is given by distance covered in the unit time, or distance by time. This is the formula of the speed. All of you must be learning it from the standard 5th, 6th, 7th, right? So when I say speed is distance by time, all of you come with me. What is the basic fundamental quantity of distance? All of you know it now. L1. What is the fundamental quantity of time? All of you know that this is time 1. This is what? This is time 1, right? So when I see this, the dimension of speed is nothing but L to the power 1. You can write 1 or you cannot write anything. If there is no power raised, that will automatically mean L1, right? Into t to the power minus 1. So if you want to write the dimensions of speed, it is going to be Lt minus 1. You can write it together also, Lt minus 1. This is nothing but your dimension of speed. Let me put it in a box. Why I am putting it in a box? Because now you understand speed. If I want to know the dimension of speed, it is nothing but power raised to the fundamental quantities, and in the case of the speed, the power raised to the distance is 1 and power raised to time is minus 1. So I hope you understood very clearly the meaning of the word dimensions. I hope you guys understood very clearly the meaning of the word dimension. This was our key word, right? This was our key word here. Now I am getting aside just so that you guys can see it very clearly, right? You can take a screenshot, you can read it, and then we will move to the further chart of it, right? All right, let us proceed. Before we proceed, please write down a note. Please write down a note. I am making this a special page where we will be writing all the notes. What are the notes? Notes are the most important points which are required for a particular topic. Like we are studying the physical quantities, units and dimensions. So these notes will be helpful in solving all the questions of the units and dimensions, right? So first note is addition and subtraction. Addition and subtraction of dimensions. This is the first note, right? What do we know about the addition and subtraction of dimensions? Any addition or subtraction of dimensions does not change the dimensions. The dimensions. For example, let me explain it with an example. Suppose I am writing a length is added in another length. That means 6 meter is added in 6 meter. What you will be getting, the result is going to be 12 meters. Meter, when it is single, it is again what? 12, or we should write it as L only. So the dimension is L to the power 1. So addition and subtraction of dimensions does not change the dimension, right? Whereas the second point is equally important. The product of dimensions changes the end results. Changes the end results. The end results, right? How? I'll just explain it to you guys. Say this. Now if I say, for example, we did this earlier also, again I'll make it. Length is 6 meters, width is 6 meters. Now what is the area going to be? The area is going to be 6 meters into 6 meters, that is 36 meters square. And when you have square, what is the meaning of it? The meaning of it is L2. So from this particular page of the note, we can conclude one thing, that addition and subtraction of the dimensions will not create any impact into the end results, whereas the product of the dimensions is going to make a very, very big impact on the dimensions, right? So just see this, I'm getting aside so that you guys can see, and I'll have a sip of water and we will proceed, right? Now I will give you a chart. Where we will be writing all the physical quantities which will be used very frequently. In this chart I will be writing all the basic quantities or the physical quantities which will be used very, very frequently, right? All right. So here I am going to write on the top, in the first column we will be mentioning the physical quantity. Here we will be mentioning the physical quantity. Physical quantity. In the first column we will be mentioning it, right? In the second column, just after it, I have just covered it with some this particular thing, right? This bar, do not get confused, this is physical quantity, right? So I have to put it somewhere, I'm putting it in the corner, right? So next thing is a formula. Which formula will be putting? See, in this particular table, what I'll be giving you is I'll be giving you the physical quantity in this particular table. We'll be having the physical quantity. I'll be writing the formula here, and then I'll be giving you the dimensional analysis or the dimensions calculated. Dimensional analysis of this we will be making here, right? So this is particular table which we are going to discuss. Now, the very first parameter which we already studied is your speed. The very first parameter which we already studied is speed. Now speed is given by S is equal to distance upon time, right? Distance upon time. So how we are going to write it? What is the dimensional analysis? Dimensional analysis says S is equal to distance is given by L1 and this is given by T1. So it will give you LT minus 1. This is the dimensional analysis of speed. This is the dimensional analysis of speed. Now, let me make the second parameter. Let me write down the second parameter. One by one, we will try to write all those quantities which are very fundamental, which are very basic and will be used again and again. And once we know the dimensional analysis of all these basic quantities, we will be very good in deriving the advanced level of these physical quantities, right? Now, the second is momentum. Momentum. I will change alternate colors. For this speed I am using green, momentum I am using white, right? So momentum is written by P, that is mass into velocity. Now, how we are going to make the analysis? This P is given by what we write for mass. For mass we write M into what are we having here? Velocity. Velocity is what? Nothing but speed. So again we are having LT minus 1. So what is the dimensional analysis of it? It is MLT minus 1. So 1 M is coming for mass. We already mentioned the notation of the mass is going to be M, and for velocity we are mentioning LT minus 1, right? So this is going to be MLT minus 1. Okay. Now, the third parameter just after the momentum. So we have done two for now. One is speed, another is momentum. Third is another very important, that is acceleration. Acceleration. Right. Acceleration. Now what is acceleration here? What is acceleration? Try to understand my point, dear students. Acceleration you must have studied in 9th and 10th class, but I am telling you again. It is the change in velocity or speed with respect to time. Whether we are increasing the velocity or we are decreasing the velocity, or we are increasing the speed or we are decreasing the speed. Change in speed with respect to time is giving you what? Your acceleration. So what is the formula? Formula for acceleration is nothing but your change in velocity. That means v2 minus v1 upon time. Change in velocity with respect to time. You can make it t2 minus t1 also, but I am writing it as t only. So v2 minus v1 upon t. And we already discussed subtraction. This is what? Subtraction. Subtraction will not make any impact on the dimensional analysis. So this is going to be what? This is going to be delta v upon t, where the dimension of v will be same as that of original speed or velocity. Why? Because subtraction or addition will not make any change in the dimensional analysis, or it will not influence dimensional analysis. So what is it going to be? This is A. Now this is delta V is what? Again your L t minus 1 into 1 by t. I am putting 1t for this particular time, which is the time with respect to which the velocity is changing. So this is going to be LT minus 2. So this is your dimension analysis for acceleration. This is your dimension analysis for acceleration. Now let us discuss the fourth point. See the acceleration. See the acceleration once again. Acceleration is nothing but change in velocity with respect to time. So change in velocity will be taken as the velocity only, because subtraction is not making any difference in what? In your dimensional analysis. And one time we are using for this time, So LT minus 1 into 1 by 2, 1 by T will be written as T minus 1 only. This will be written as what? Let me summarize it again. LT minus 1 into T minus 1. So final result is going to be, just in case I skipped one step, considering that you people are very intelligent, you people are very smart, but if you are not getting it still, T minus 1 I have written again. So it will be what? LT minus 2 is going to be the end result. LT minus 2 is going to be end result. The same we written, but 1 by T in the future also I will directly write it as T minus 1. 1 by T in the future also I will write directly as what? Your T minus 1. Okay. Next is your surface area. Next point is your surface area. This is a very, very important table, and this is going to help you a lot. See, I'll tell you first of all, before we proceed further, in the physics we'll be using it some or the other places. On the next slide, I'm explaining you the difference between cross-sectional area and surface area. I hope you must be knowing it. Even if you do not know, you will be able to understand it right now. One is surface area, another is cross-sectional area. Now, see, for that I'll be needing a shape. And let me erase some part of it so that I can put the shape in half part, right? Let me see if I have a 3D shape with me, right? If I have a 3D shape with me, let me see. Yes, this is what we have. Now, just see this. Let me decrease the size if I can. Yes. Now see this once, every one of you, see this. When I'm showing this to you, right, when I'm showing this to you, we can see a surface. Let me fill the surface for you guys. This surface is seeming green to you. This surface should seem green to you. Let me fill. This is this surface. Now see, it is already yellow now. One portion you can see is this yellow portion. This portion is yellow. Now this portion is covering the surface. Now which two parameters are involved in the surface? This concept you should be able to understand right now, because when we'll be moving to further topics, this concept should be very clear in your mind, right? When I'm considering the surface, which two parameters I am involved in? Which two parameters are involved? I'll explain you. Say this, beta. This is the first parameter.